Good afternoon, friends. Last class, we have been talking about Klebsiella, Proteae, and some of the Enterobacteria here. This class, we will talk about a problem which is all over the world, also in India. And a vaccine used for that, peculiarly, it may have a role in combating the COVID-19 pandemic. So, Melinda Gates, Bill Gates, the foundation announced last May 14th that they're going to give $10 million to help fund an Australian trial. Anyway, point is Mycobacterium tuberculosis. So, what do I expect by the end of this session? I expect that you should be able to classify Mycobacterium tuberculosis and then write about the growth on Levenstein-Jensen medium, and also write about the Mycobacterium tuberculosis laboratory diagnosis, and also to say a few words about BCG and write about MAN2 test. Anyway, those are my aims. Let us see how far I can be successful. Coming to the introduction part. Why the name Mycobacteria? Myco means, something like fungus. Why does it get that name? They are slender rods, branching, filamentous forms resembling fungal mycelium. That's why they are called Mycobacteria. In liquid culture, a mold-like pelican. So, it looks like a fungus, as if there is a fungal growth. So, that's why, again, it's called Mycobacteria. They're not readily stainable, but once stained, they resist decolorization with dilute mineral acids. So, they are acid-fast bacilli. So, in a word, slow-growing, aerobic, non-motile, non-capsulated, and non-spore-bearing acid-fast bacilli. They are your Mycobacteria. So, three groups. They are either obligate parasites, that means they can live only in a host. Some of them are opportunistic pathogens, that is, given a chance, they will cause disease. Saprophytes available in the surrounding environment. So, Mycobacterium tuberculosis complex, that's where it's called. It's not just Mycobacterium tuberculosis only, it's a complex. So, Mycobacterium tuberculosis is a human part. Bovis that causes in cattle. Mycobacterium africanum, microtype in wolves and other mammals. Recently, some are added, like it's only for completion's sake. It's not as if you should remember all these things. Caneti, Capre, Pinnipedi. Though Mycobacterium leprae is also under this, it was found out fast. But still, it is the second human pathogenic Mycobacterium because it is not cultivable in vitro. So please, when you become house surgeons, don't ask for culture of Mycobacterium leprae. Even today, we get requisitions. Please do culture of the skin tube. We are expecting Mycobacterium leprae because we cannot do any culture of Mycobacterium. Mycobacterium leprae. It may be given also as a big question. The following, one of the following is not cultivable. So the answer, Mycobacterium leprae. Maybe that's why it is poorly understood also. Coming to opportunistic pathogens, non-tuberculous Mycobacterium, NTM, there's a mixed group. And what are the sources? I have a small mnemonic, SUB, Web, you are all familiar. We are all having web classes, web seminars. SUB, subject microbiology. So combine both that soil, ulcers, birds, water, environmental, either cold-blooded, warm-blooded animals, all these things, they can occur in the environmental companions, okay? So broadly classified as non-tuberculous Mycobacteria, photochromosomes. That is, they produce pigment in the presence of light. Scotochromosomes, without light, that is the night time, they produce pigment. Non-photochromosomes, whether light is there or not, they produce pigment. And rapid growers. This last category is very important because they confuse us. So this is the classification of non-tuberculous Mycobacteria. And saprophytes, Mycobacterium flea, PHLEI, the grown grass. Mycobacterium smegmatis, you may be misled by the name. For seldom found in smegma, but still it is named as Mycobacterium smegmatis. But why should we know about these things? Often contaminate urine cultures along with other rapid growers. So they cause some diagnostic difficulty. That's why I should know. Now coming to Mycobacterium tuberculosis, striped, slightly curved rods, about 3 microns in size. Singly or in pairs or at angles or small clumps. The size actually depends on growth conditions. Long filamentous, club-shaped and branching may be seen. That's why I said myco. But again, Mycobacterium bovis is usually straighter, shorter and stouter. So remember, straighter, shorter and stouter. If you think about bovis, natural infection in cattle, humans, other primates. Experimentally, guinea pig are highly susceptible, rats moderately, and BCG vaccine is an attenuated strain of Mycobacterium bovis. So when you are asked to write a short notes question on Mycobacterium bovis, you can write about the special features of M. bovis and also add that the BCG strain is nothing but an attenuated strain of Mycobacterium bovis. So these are a few differences between the Mycobacterium tuberculosis and Mycobacterium bovis. And tuberculosis, as you know, is having a human host, whereas bovis is from a bovine host. Niacin test, it is positive in case of tuberculosis and negative in case of bovis. Why I'm telling you at the beginning itself, you might get a short note switch and write at least 4 differences between Mycobacterium tuberculosis and Mycobacterium bovis. So, question paper oriented, we have to remember at least about 4 differences. Colony, dry, rough, raised, irregular, wrinkled surface in case of tuberculosis. In case of bovis, it tends to be flat, smooth, moist, white, and break up very easily. So, nitrate test positive and nitrate is negative in bovis. Aerobic tuberculosis, Mycobacterium tuberculosis, it is grown in the lungs, in human beings. That's why it is aerobic. It requires good supply of oxygen. Whereas bovis, microaerophilic, so it can tolerate even the oxygen tension is a bit low. And growth in T2H, that is positive in case of tuberculosis and negative in bovis. This T2H we'll see a bit later. Mycobacterium tuberculosis eugonic culture, that is luxuriant growth you expect. And Mycobacterium bovis, you don't expect dysgonic culture. So it's a sparse growth. 0.5% glycerol, the growth is increased. Glycerol bile potato medium, the growth is increased, whereas there is no effect in case of bovis. And twin 80 hydrolysis. Twin 80 hydrolysis is positive in case of tuberculosis. In case of bovis, it is negative. So these are a few differences. Now, coming to staining of Mycobacterium tuberculosis, this you will have a practical demonstration, and that's why we don't go into the practical details much. So once you come to practical classes, or maybe we can even arrange to show a video as to how it is to be done. But right now, we will see about the staining techniques, Gilnason's acid-fast staining technique. You can also do a fluorescent staining that I used as aramine O and rhodamine. How do you do the acid-fast staining technique? They resist decolorization by 20% H2SO4, so they are called acid-fast bacilli. H2SO4 is sulfuric acid. Why this is acid-fast? And again, if it is tuberculosis, it is 20%. It is lepre, it is only 5%. So acid fastness is due to mycolic acid. It's an unsaponifiable lipid-rich wax material, or to a semi-permeable membrane around the cell. So mycolic acid, you might get a sharpness question. You should say the character is because of mycolic acid. Acid-fast staining because of mycolic acid. When you study about the Staphylococcus, you studied about spheroplasts and alpha-forms. So Mycobacterium tuberculosis, grown in the presence of lysosomes or lysozymes, you have the growth of spheroplasts here. Please remember that you are not supposed to say whether it is gram positive or whatever, because the membrane is not permeable to the very dye itself. So, though it looks gram positive, it is not relevant to talk about gram staining as far as Mycobacterium tuberculosis is concerned. But you can say that it is gram positive because the primary dye itself is not penetrating. Mycobacterium tuberculosis is both acid and alcohol fast. It traces decolorization with 3% hydrochloric acid in 95% alcohol. Whereas saprophytic mycobacteria, they are only acid fast, but not alcohol fast. So this is one important thing to remember about saprophytic mycobacteria. The difference is the normal Mycobacterium tuberculosis is both acid and alcohol fast, whereas saprophytic mycobacteria, they are only acid fast but not alcohol fast. Coming to the cultural characteristics, slow growers. That is why when talking about rapid growers. In case of non-tuberculous mycobacteria, we said rapid growers. Here, they are slow growers. Generation time, 14 to 15 hours, a doubling time. Colonies appear in 2 to 8 weeks. Lowenstein, Jensen medium, you inoculate, and you see once in 2 weeks up to 8 weeks. Optimum temperature, our body temperature, 37 degrees centigrade. Temperature below 25 or above 40, it's unfavorable for growth. Optimum pH, 6.4 to 7. Again, we saw the differences. Mycobacterium tuberculosis are complete error. Unless good oxygen supply is there, it can't survive. Bovis microaerophilic, even in a reduced oxygen tension, it still can survive. Eugonic and dysgonic, we already explained, luxuriant growth in case of tuberculosis. In case of bovis, it is not so sparse growth. Susceptibility to toxic substances. In culture media, you have at times fatty acids. The bacilli are highly susceptible, and such susceptibility can be neutralized by charcoal or serum albumin. Coming to the classification of culture media. The most commonly known used medium is Lowenstein, Jensen. Please write the spellings carefully. Though you pronounce as LJ medium, please remember that Lowenstein, Jensen medium. Most widely used protein culture contains about coagulated hen's egg. Why this coagulated hen's egg? Okay, the nutrition part is fine, but it is used as a solidifying agent. Why I am telling you this is, often a big question is asked, the agar percentage of Lowenstein Jensen's medium is 6%, 4%, 2%, nil. So please say that it doesn't contain agar. Okay, so Loeffler serum slope, again another medium which doesn't contain agar. The name itself indicates it is serum slope. Okay, so Lowenstein Jensen medium, no agar. Instead, the coagulated hen's egg and MSS, mineral salt solution, and asparagine. Malachite green is a selective agent which inhibits the growth of other bacteria. What other media you have? Again, solid and liquid. In solid, sorry about the spelling mistake, SOLID should read. Egg-based Petragnini and Dorset medium. Blood-based Toshi's, serum-based Loeffler serum slope, I told you. Potato burst, Pavlovsky's medium. Liquid, Dubose with Finati, Edelbroots, Proscaret Bex, Sula, and Short. Newer methods of cultivation. To detect the early growth, you can use Bactec 460, Bactec Alert, Bactec MGIT. A rapid growth detection method, they use 7H9 Middlebrook medium, and fluorimetric detection technology via oxygen consumption. That is, if above the medium, whether you can assess the consumption of gases or the gases that are released by the dividing tubercle bacilli. So the pressure changes, they can be detected. So these are all rather not necessary, but nice to know. Another thing like that is ESP system, extra sensing power. This is what I was referring to earlier. Bacterial growth is detectable by either consumption of gas or liberation of gas. So this ESP, it measures the pressure changes. And you can still detect the bacterial growth, and also by a recent modification, you can detect the drug susceptibility also. Coming to the resistance exhibited, the bacillus is killed at 60 degrees centigrade if you expose it for 15 to 20 minutes. But remember, why the tuberculosis is so much rampant is in sputum it can survive for 20 to 30 hours. So treat carefully the sputum samples. As a microbiologist, we regularly do the sputum microscopy. But in sputum, a positive patient, they can be alive up to 20 to 30 hours. And droplet nuclei, the route of spread is droplet nuclei, and they can stay alive for 8 to 10 days. And cultures, if you're doing tuberculosis culture, be very careful. 6 to 8 months they're alive. And for storing minus 20 degrees centigrade, up to 2 years they're alive. So be very careful while you're handling cultures. And the routine hospital disinfectants which you use, 5% phenol, 15% sulfuric acid, nitric acid, 3% and 5% oxalic acid, and 4% sodium hydrochloride. They can survive exposure. But killed by formaldehyde from formalization or formaldehyde vapors in theater. And again, glutaraldehyde in your classes about theater sterilization or sterilization as such. We told you about formaldehyde and glutaraldehyde. So it's killed like that. Tincture iodine. In our very young days, they used to tincture iodine seal for any small bruises. So tincture iodine for 5 minutes, destroyed by that. And 80% ethanol, 2 to 10 minutes. That is, you must allow the contact for 2 to 10 minutes. Then only it is destroyed. That is why it is a suitable disinfectant for skin, gloves, and clinical thermometers. Some people might ask you, how do you use clinical thermometer? So the best thing is ethyl alcohol, because you can't heat a thermometer by autoclave or by hot air oven. So what you're supposed to say is ethyl alcohol. Biochemical reactions. It's not as if you have to remember all these things, how to do the test and all. But just remember, niacin test is positive. Aryl sulfatase test, it is positive only in case of non-tuberculous mycobacteria. Catalase peroxidase tests, they are to differentiate between tuberculous bacilli and atypical mycobacteria. Nitrate reduction test, again, positive in case of Mycobacterium tuberculosis, negative in case of bovis. Amidase, it is positive. Pyrazine amidase is positive. Inhibition by thiophene 2-carboxylic acid, T2H. Sometime back I was referring to the differences of Mycobacterium tuberculosis and bovis. There, the growth in case of T2H, to differentiate this test is useful. Neutral red test, virulent bacilli, they adsorb to neutral red. Twin 80 hydrolysis is again positive. So as I told you, don't go into the detail of doing the test. And remember, it's negative in bovis, but positive in tuberculosis. And aryl sulfatase, positive only with atypical mycobacteria. Catalase peroxidase. Remember that tubercle bacilli, peroxidase is something to do with oxygen, as the name suggests. Strongly positive for peroxidase and weakly positive for catalase. Whereas iron H, resistant bacilli. Loss of both of these activities, catalase and oxidase, negative. Okay, don't go into much detail about this, like you can, how to do the test and all. It's only for completion's sake. I am giving it here. And coming to nitrate reduction, Mycobacterium tuberculosis is positive, whereas Mycobacterium bovis is negative. Amidase to differentiate various mycobacteria. Again, I have a small mnemonic, ABC and P. ABC is what amide? Acetamide, benzamide, carbamide, nicotinamide, and pyrazinamide. So these amides, they have an amidase in the bacilli, and it can split these amides. Pyrazinamide test. Pyrazinamide, it is positive after 4 days in case of Mycobacterium tuberculosis, negative in case of bovis. Again, T2H, Mycobacterium tuberculosis is resistant. That means it can grow even in the presence of T2H, whereas Mycobacterium bovis cannot grow. Neutral red, avirulent TB bacilli cannot bind neutral red, whereas virulent bacilli can bind neutral red. Twin 80 hydrolysis is negative in case of Mycobacterium bovis, whereas tuberculosis is variable, and also species differentiation is possible in non-tuberculous Mycobacterium. Coming to the antigenic properties, as I tell you time and often, why should you learn about the various antigens? Two things. One is antigens produce antibodies. Antibodies may be protective or may not be protective. Why should we know? So, if we know that the antibodies are protective, yes, we can use some serum therapy. Take the antibodies, give them before you find out a vaccine, or before you use a drug, we can use the antibodies. Or you can also see whether a vaccine can be produced. Which antigen is giving the disease, and against that part, shall we produce a vaccine? So that is why antigenic structure is very important. Now, what are all the antigenic components? We have lipids, we have proteins, and we have polysaccharides. Coming to lipids, please remember, mycolic acid can be a short cross question. Again, there is a typing mistake. Mycolic acid. MyColic, mycolic acid. Role in pathogenesis is there, and why the disease is caused? Because of mycolic acid. And PGL, peptidoglycan layer, it gives shape to the cell, and also it gives strength to form granuloma. And also the pattern of lipids, gas liquid chromatography, GLC, gas liquid chromatography. And cod factor, this is responsible for virulence. So this you have to mention when you are given a short course question about mycolic acid. Okay, we have seen about lipids. What about proteins? Usually you do a test, PPD, purified protein derivative. So it induces delayed hypersensitivity, but its role in pathogenicity is not clear. So that is about the proteins. And the last variety, polysaccharides. Remember, we talked about polysaccharides in gram-positive organisms, pneumococci. Here again, the group specificity, that is Mycobacterium, which group and all, that specificity is because of polysaccharides. Again, role in pathogenicity is not very clear. So please remember, it is only lipids, the mycolic acid, that is very important. And responsible for immediate hypersensitivity. So polysaccharides, they are responsible for immediate hypersensitivity. And then antibodies, as I was telling you, the antigenic fragments can produce against polysaccharides, against proteins, and against the phosphatide antigens of TB bacilli, but they have no protective value. And they have no diagnostic relevance also. Then what for? Enough if you know that they are antigenic. Okay? Would have been much happier had they been protected. Okay? Anyway, we have to type these bacilli. Like typing methods, there are so many. But why typing at all? One is their distribution is explained geographically. So, for example, in India, the Mycobacteria tuberculosis, so much, so and so strain is more powerful or more rampant, something like that you can say. Whereas in Africa, it's not so much. So, like that, you can give a geographic distribution and an explanation. And also in the environment, the routes of transmission and dissemination. And you can also trace the source in man or animal. So that is why the typing methods are important. Genotypic and phenotypic methods. And we discussed bacteriophage typing. Bacteriophage is the viruses that eat away the bacteria. So we have A, B, C. That is, just like you say, the ABCs of any topic. So you can say A, B, C are bacteriophage types. And between type A and type B, we have an intermediate type. So that is about the bacteriophage typing. Coming to bacteriocin typing. Non-tuberculous mycobacteria, they produce bacteriocins. The rapid growers, you can easily identify them by typing methods. Okay. Why these molecular methods? Can do, like regular culture. But as you know, it takes 2 to 8 weeks for culture, whereas there's molecular typing methods take less time than culture, are more sensitive. Even one bacillus for 1 ml of specimen, they can identify. Because at least 10,000 bacilli are there, they cannot be visible. Okay, so each time you cough, some 3,000 bacilli are spread. So then only you can infect. So it is very sensitive. It can detect even 1 bacillus per ml of suspension. Extra pulmonary samples. Pulmonary samples, okay. As I said, like while you cough, if it is an open case, you can have a lot of tubercle bacilli. But whereas in extrapulmonary, the bacilli are very less. That's why it's called quasi-bacillary. In such cases also, the molecular typing is very useful. And you can detect drug-resistant genes. And it's used for epidemiological typing of strains. The community medicine people require these epidemiological typing. So what are the methods? You need not know about all the details, but enough if you can. Just roll out some names. PCR, polymerase chain reaction. CBNAT, what is this abbreviation? CB, cartridge-based, NA stands for nucleic acid amplification test. Okay, CBNAT is cartridge-based nucleic acid amplification test. And you hear we are using GenExpert. So GenExpert is a trade name. And this is endorsed by WHO, World Health Organization. LPA, line probe assay. TrueNAT, so this is a chip-based real-time PCR. All these tests are available in the Drug Susceptibility Testing Laboratory, DST, available in our Visakhapatnam itself. Okay? Excuse me. Some more tests. Loop-mediated isothermal amplification, TB lab. VOC, volatile organic compounds, breath biomarkers, and lipoarabinomannan in urine and sputum. IRISA TB, don't worry about all these things. TST, MODS, that is microscopic observation of drug susceptibility. What are the changes? Whether you can see the smear and say, if you can differentiate a fellow who's taking drugs or not taking drugs, what are the morphological changes? I think at undergraduate level, it's too much to expect from you. But enough if you remember that you can see the slide and you can make an educated guess about the treatment, whether it's adherent to or not. Colorimetric redox indicator. So these are all some of the molecular techniques. Mostly based on DNA fingerprinting technology, RFLP. That is, it's a nested PCR, spoligotyping. So all these things, it is only for the value of remembering, in case what are all the newer molecular typing techniques. Definitely they will not be asked in undergraduate question, but postgraduates, yes. So these are some of the things like transcription-mediated amplification, TMA. So anyway, I think it's too much. Coming to host range. Natural infection can be caused in human beings and other primates, dogs and other animals, pets. So be very careful. Experimental animals highly susceptible is guinea pig. Hamsters moderately susceptible, mice. Infection, how the various routes, intraperitoneal, intravenous is more rapid, and in IT, intradermal inoculation, much more fast. Extrapulmonary, it is less virulent. Coming to general account of tuberculosis is potentially fatal infection, especially in earlier days, TB was very much feared, but right now we have drugs. And the state is giving good support. The National Tuberculosis Elimination Program by the Government of India. Earlier it was called RNTCP, Revised National Tuberculosis Control Program, but from January 2020, it is known as National Tuberculosis Elimination Program. Okay, so most common organ infected is the lungs. That's why it's called pulmonary tuberculosis. Rest of all is extrapulmonary tuberculosis. Coming to the source of infection, an open case, it can infect before death, or even cured case. So no age is exact. Mode of infection by either coughing or sneezing, or when you speak, the aerosols are there from open case. And I was talking to you about the infectious nuclei per cough. They are about 3,000 they're released. And in an open case, 1 ml contain around 10,000 bacilli. If you are seeing under microscope, the sputum may be having a minimum of 10,000 bacilli per ml of sodium. Ingestion, as we told you, Mycobacterium bovis infected milk from a cow or a buffalo. So the infected milk ingestion. Very rarely, inoculation also can cause. Coming to the immunology part, the various components of TB bacillus. have different biological activities. They influence the pathogenesis, allergy, and immunity to infection. So we were discussing about the mycocytes in the cell wall, the mycolic acid, and also the arabinogalactan layer, the peptidoglycan layer, and the cell membrane. Okay, so the mycolic acid, when a short notes question is asked, this figure will be helpful to you. So antigenic structure we have discussed, and in the cell wall, we have insoluble antigens, that is cell wall insoluble antigens are PGL, that is peptidoglycan layer, arabinogalactan layer, and outermost layer, and the plasma membrane. These are cell wall insoluble antigens. Cytoplasmic, that is in the cytoplasm, soluble antigens are there. 5, 6, and 60, they are used for serodiagnosis. So peptidoglycan layer, as you know, it gives shape and rigidity. Arabinogalactan layer, survival in macrophages, because intracellular host. Okay, these are, they survive in the cells that are macrophages. They survive in the macrophages of the host. This is an advantage because antibiotics cannot easily pierce the macrophage. As I told you, mycolic acid can be asked as a short notes question. Principal constituent of the cell wall is a long chain fatty acid, and it is attached to arabinogalactan layer, confers low permeability to cell wall, and responsible for the acid fastness, reduces entry of most antibiotics and outermost layer, and it consists of lipids, and that is what you are supposed to write. Okay, so please remember, mycolic acid can be a short notes question. Okay, coming to the proteins, you have the transport proteins, they're called porins, and seen throughout the various layers. I think that is sufficient if you know. Again, to refresh, mycocytes, mycolic acid, and the arabinogalactan layer. Peptidoglycan, which is giving shape, and the cell membrane, these are giving the shape to the vascular. Host immune response. This is very important. You know, whether we get a disease or whether we resist the disease, it depends on the immune response. So, cell-mediated immune response, if we take, the macrophage presents the TB antigens to TH cells, and the TH activated into TH1 and TH2 subsets. TH1 cells, they release cytokines IL-2 and interferon gamma. In turn, they activate the monocytes and macrophages. So thus the activation of TH1 leads to macrophage activating response and tissue damaging response. So naturally, tissue damaging response leads to a lot of destructive things, whereas macrophage activating response is a protective response. So between A and B, that is the macrophage activation and tissue damaging, the outcome is decided. The balance between the two decides the outcome. And after TH1, we have TH2. So they secrete the cytokines IL-4 and IL-5, interleukin 4 and interleukin 5. They activate the B cells to produce antibodies. But Mycobacterium tuberculosis is an obligate intracellular parasite. That's what I've been telling you. They reside in the macrophages. And so the antibiotics cannot pierce. So we don't know much about the response to these particular humoral immune response, whether it is protective or not. No, there's a very minor role to play. But anti-ALM antibodies, they play a role in preventing dissemination of tuberculosis bacilli in children. Now, some old-timers may still ask you, what is Cox phenomenon? Now it is not relevant, but still it's historical importance, you must know. You take a healthy guinea pig and you take a guinea pig that is exposed to tubercle bacilli by injection at the end of 2 to 4 weeks. What is the response? If you take a healthy guinea pig, which is not at all exposed earlier, there is no immediate local reaction. A nodule at the site of inoculation, 10 to 14 days, it may appear, gets enlarged, and draining the local lymph nodes, caseation can be there, progressive tuberculosis of several organs, and gradual death of the animal. Whereas, if you take a guinea pig that is exposed to TB bacillus 4 to 6 weeks earlier, there is an induration, that is local induration is there. Within 2 to 3 days at the site of inoculation, it progresses to become a shallow ulcer. There is no local lymph nodal involvement. You take up the healthy guinea pig which is not exposed earlier, the local lymph nodes are involved, they're enlarged, they become caseous and all that. But here there is no such local lymph node involvement, and it heals without systemic involvement. So that is the difference. Now, let us know something about the tuberculin test, originally prepared by Robert Koch. Please don't pronounce it as Koch. K-O-C-H is pronounced as Robert Koch. So originally it is called old tuberculin, CBER modified it as PPD, purified protein derivative. Later use also PPD, highly purified protein derivative. That is what is in correct use now. This is primary complex, secondary adult tuberculosis. All this is the domain of medicine, specialty, but still basics. Primary tuberculosis, one focus, primary complex. Post-primary, that is secondary, adult tuberculosis. So some detail about this, one focus, and like where it occurs, what are all the clinical features, what happens to the feet. That is, in the majority of cases, the lesions heal spontaneously. The primary complex becomes, rarely in children, it can impair the immunity. Progressive primary tuberculosis develops and spreads by local invasion and by lymphatics. I told you this is all will be taught to you again in medicine. So I don't dwell much upon the Gons lesion or Gons focus and the adult tuberculosis. Okay. But you should know something about the pathology part of it. We have exudative type and we have productive type. Exudative type, as the name itself suggests, acute inflammatory reaction with accumulation of edema fluid and polymorphonuclear leukocytes. Productive type, predominantly cellular, associated with protective immunity. So this is where you can distinguish whether the outcome is going to be helpful to the host or not helpful to the host. So the development is either hard tubercles or later on they become soft tubercles. So initially the tubercle is hard. There is a central zone of activated macrophages. Like we told you, the Th1, Th2 activation of macrophages. So you have activated macrophages. There is a central zone and peripheral zone of lymphocytes and fibroblasts. Whereas in case of a soft tubercle, there is a central caseation, soft, cheesy, putty, necrotic material, low oxygen tension. And then there is inhibition of growth of bacilli and calcification. And that is where you call it as a soft tubercle. As you can see, the tubercle is granular one with caseation in the center. So where from the tuberculosis can affect what? So open case of tuberculosis, pulmonary tuberculosis. In Mycobacterium bovis, as I told you earlier, it is unpasteurized and infected milk. Mode of transmission, inhalation of droplet nuclei. As I told you, it can stay alive for 8 to 10 days in droplets. Coughing, sneezing, or speaking to the infected patients, definitely. Each cough releases around 3,000 droplet nuclei. They're tiny droplet nuclei about the size of 5 to 10 microns. So, coming to the epidemiology. So, 1/3 of the globe is infected. 2 billion. Every year, 8 to 9 million of new cases, and every year 3 million die. A very sad state of affairs. Even today, when we have treatment, we are unable to prevent this spread. That is why the National Tuberculosis Elimination Program. Earlier it was RNTCP, now it is National Tuberculosis Elimination Program. India is one of the worst affected countries. More than 40% infected, and we have very heavy caseload in the sense. More than 1/3 of the positive burden is from India. So 1 death every minute. It's a very frightening statistics. So what are the risk factors? Exogenous risk factors. Sputum positive patients. How do you know they're sputum positive? We're doing a DNA test. And if it is positive, 10 to the power of 4 bacilli per ml of sputum. That is the bacillus load in a sputum positive patient. And adults with cavities in lungs, like radiological evidence. Overcrowding and poor ventilation. This is something really difficult to tackle from most of the below poverty line. They are having overcrowding and poorly ventilated rooms. And what are the endogenous risk factors? Low CMI, cell-mediated immunity. It is rather low as in HIV-infected patients. And what is the age? Late adolescence and early adulthood, they are the most susceptible age groups. Sex, females at 25 to 34 age group. Men are at an older age, they are susceptible. And comorbid conditions like chronic renal failure, diabetes, hemodialysis, smoking, post-transplant. Why post-transplant? Means you are using immunosuppressive drugs and intravenous drug abuse. So all these people, are susceptible, and they are endogenous risk factors. Coming to the sequence of pathogenic events, droplet nuclei, as I told you, mostly they are given out. You know, when I say about the cilia in the nose, they drive out. But still, at 10%, they reach alveoli. And addition to macrophages and phagocytosis, the C3b mediated opsonization. So these are important. And coming to the consequences, as I've been repeatedly telling you, intracellular survival is to the advantage of the bacillus inside the macrophage due to the presence of LAM, impairing the formation of phagolysosome. If you remember your immunology classes, phagosome, lysosome, combined to form a phagolysosome. And this is the host defense is reduced by the presence of LAM because it is impairing the formation of phagolysosome. And just like the terrorists, they are taking hostage in a place of prayer, like a Gurdwara or a temple. The bacilli also, they take a sort of umbrage in the macrophage. So they replicate in the macrophage. And again, the macrophage ruptures eventually and release of bacilli. And the infection continues. So intracellular habitat is one very important thing. And I told you macrophage activating response and tissue damage response. These are the two important things. So in majority of cases, 90% show resistance. And they contain the bacilli, no disease. So though we have the Mycobacteria tuberculosis bacilli inside, we don't show the disease because we have some resistance to it. Interferon gamma, it activates the resting alveolar macrophages to activated macrophages, which can kill and digest the tubercle bacilli. The tubercle formation is a favorable sign. That means the body is fighting against the presence of tubercle bacillus. And it's an essential pathological finding. So, the formation of hard and then soft tubercle, it is an indication that our immune system is working against tubercle bacilli. And I was referring to you about the tissue damaging response. At times, the bacilli or the bacteria are virulent, and we have a weak macrophage activating response. Then we have intensified delayed type of hypersensitivity, delayed mycobacterial growth, lung tissue destruction, caseous necrosis, and further liquefaction, radiologically evidenced by cavity formation. And once the growth occurs of the bacilli, they can spread by 3 ways. Direct drain into airways. That is, we told you the Mycobacterium tuberculosis is mainly in the lungs, pulmonary tuberculosis. So they may directly drain into the airways. So whether you cough, whether you talk, you can drain into the airways. Or lymphatic spread, receding in same or opposite lung, or disseminate to other organs. So by lymphatics, they can spread into the opposite lung or disseminate into other organs. And the main layer, that is the hematogenous spread to various other organs also can be there. So this is where we have to be very careful. That is the delayed type of hypersensitivity, formation of cavities in the lung, and spread by coughing, sneezing, talking, and lymphatic spread, receding in the same or the opposite lung, or due to dissemination by lymphatics into various other organs. More dangerous is hematogenous spread to various organs. So let us summarize as to what we have seen in the past few minutes, almost reaching up to an hour. We have seen about the classification of tubercle bacilli. Yeah, one thing I forgot to tell you in classification itself. You can say cultivable and non-cultivable. I just told you that Mycobacterium leprae cannot be cultured in the laboratory. So they are non-cultivable. Whereas Mycobacterium tuberculosis, bovis, all these things are cultivable. And we have also seen what are all the various methods of staining the tubercle bacilli. And also we have seen the various components that can behave as an antigen. Whether the antibodies produced are protective or not, they do produce antigenic response. And in tuberculosis, most of the antibodies are useless. And we also have seen the various tests and how they're useful in speciating the non-tuberculous mycobacteria, or how to differentiate between Mycobacterium tuberculosis and Mycobacterium bovis. And also we have seen the pathology involved, that is the hard tubercle, the soft tubercle, and what is the importance of or the consequences of the mycolic acid that is there inside the cell wall. And what happens once the tubercle bacillus enters the body. So these are a few things we have seen in this class. And next class, maybe tomorrow, we will see about the laboratory diagnosis of tubercle bacilli, something about BCB, something about the Manto test, all these things we'll see in the next class. Bye. See you. And you better get prepared for tomorrow's class also. And this presentation will be on the website of our college. You can see and revise. Okay? And forgive me for the typographic errors. There are some which escaped my attention. Thank you. Let's meet again tomorrow. Bye. Every